Welcome back to AI in Real World. This is part 3 of a 3-part AI Weather Agent series, and we have come a long way. In part 2, we created an AI chatbot using Pydantic AI framework, and we also added forecasting ability to our agent. In this video, we're going to add a user-friendly interface and add voice interaction to our chatbot. You will learn how to create UI for your chatbot using Streamlit, how to add voice input and output to our chatbot. We'll also explore alternative options for text to speech. And finally, we'll discuss ideas for extending the project and make it even more useful. We'll be using Streamlit to build the UI for our chatbot. Streamlit is a Python library that makes it incredibly easy to create web applications. It's perfect for quick prototyping and sharing your AI use cases. Streamlit requires minimal front-end web development experience. You can quickly build a functional and attractive UI using Python code. The code we are going to look is in the same project we saw in part 2 of the video series. This entire project is in Git and the link to the Git is in the description. To get the code working, clone the repo and install all the dependencies using install -r requirements.txt command. All the required dependencies are in the requirements.txt file. Check the README file as well. It has all the information you need. Here is the high-level component architecture of our implementation. We record the audio that we speak with the microphone as the input using the speech recognition Python library by calling the listen method. This audio is then converted to text by calling the recognize Google method, which is also part of the speech recognition library. Once we have the text, which is the weather question from the user, we send the question to the agent, which then uses LLM and appropriate tools to get us the response. The response will be in the text. Now we have to convert the text to audio to play it back to the user. To convert text to audio, we will use GTTS, Google Text-to-Speech Python library. Once we have the audio, we will use the JavaScript's audio library to play it from the browser. Now, this weather agent isn't just smart. It is interactive with the UI and even responds with voice. If only your business had a virtual assistant that could handle customer questions that smoothly. If you are a business owner looking to integrate AI into your operations, book a free consultation call with us. Let us help you build AI that not only works but communicates for your business. Link is in the description. Now that we understand the architecture, it will be super easy to follow the code. Let's dive into the code from our Streamlit app. The name of the Python script is weatheragentvoice.py. First, we import the necessary libraries, including Streamlit, speech recognition, GTTS, OS, etc. Let's first examine the recognize speech function. This function is responsible for capturing users' voice input and converting it to text. It starts by creating a recognizer object from the speech recognition library. Then it opens a connection to the microphone using the microphone class. The listen method listens for audio from the microphone. Once we capture the audio, we will call the recognize Google method to convert the audio to text. Let's now look at the speak function. This function takes a text as input, converts it to speech, and plays the audio in the Streamlit app. This function will be called to play back the response from the agent. First, we create a GTTS object from the GTTS, that is, Google Text-to-Speech library, specifying the text to speak and the language as English. We then create byte.io object to create the audio data in memory and writes the audio data to this object using the write-to-fp method. The audio data is then encoded to base 64, which is required for HTML audio output. The code constructs JavaScript code to dynamically construct the audio output in HTML, then inject it to Streamlit component to play the audio. Finally, it uses st components v1 HTML function to inject the custom HTML and JavaScript code into the Streamlit app, which plays the audio. The reason we are using JavaScript to play the audio back is because we want the browser to take care of the audio playback. So when we deploy our Python code into a server, the audio playback will still work. If we use Python libraries to play back the audio, it will seem to work locally when you run the script from your laptop. But you'll fail to hear the audio when the Python code is not deployed locally. getWeatherResponse function handles the interaction with our weather agent. It takes the user query, interacts with the weather agent, and returns the agent's response. We first initialize a dependency to weatheragent.run. which we covered in the part 2 of the series, which we implemented using Pydantic AI framework. The code is inside weatheragent.py file in the same project. We looked at the code of our weather agent in detail in part 2 of the series. Link is in the description. But here is a small recap. Our agent uses an LLM and 3 tools. lat-lang tool to get the location, get weather to get the current weather, and get forecast to fetch the forecast. We tie the LLM and tools together using the Pydantic AI agent framework. For a detailed walkthrough of the code, check out part 2 of the series. Now back in our code, we call the weatheragent.run with user message to create a response. Next, we have the send message function. This is the heart of our application, handling both text and voice input and orchestrating the interaction between the user, the weather agent, and the UI. First, it checks if the user provided input either through text or voice, and then append it to session state.messages list for maintaining the chat history. The function handles the get weather response to get weather information and respond it back to the users. A try exception block is implemented to capture any errors. Now let's examine the main app layout and logic, which is built using Streamlit components. The line st.title sets the title of the app. Then we have a button named Speak. When a button is clicked, it calls a recognize speech function to capture the voice input and sets the session state user input and calls send message to process the voice input. We also have a text input field where user can optionally type in their questions. The onChange send message argument specifies that the send message function should be called whenever the text in the input field changes. Finally, the script iterates through the session state message list and displays the chat history in the UI using Markdown. The messages are styled differently depending on whether they are from the user or the agent. Now let's see the app in action. I'll run the weather agent voice script using Streamlit run weatheragentvoice.py. Let's hit enter. Streamlit will automatically open the browser and load the application. Now I can interact with the chatbot using the UI and my voice. Alright, let's go to try. Do I need a jacket in Chicago tomorrow?
Yes, you'll likely need a jacket in Chicago tomorrow as temperatures will range from 7 degrees Celsius to 13 degrees Celsius.
And there you go. The chatbot correctly understands my voice input, fetches the weather forecast, and provides a spoken response. Since the main architecture from Weather Agent did not change much in the process, the log analysis is exactly the same as we saw in the previous video. We are using Logfire to monitor the agent's behavior. Open the Logfire project URL to see the detailed logs of the interaction. You must note the speech recognition library and GTTS library have their limitations, and they are of low quality. There are better options out there, each with its own strengths and weaknesses. Google Text-to-Speech API offers high-quality voices and more customization options, but requires a Google Cloud Platform account and comes with usage costs. Another powerful option for voice and text-to-speech is Eleven Labs, a powerful AI voice platform that allows you to create highly realistic and expressive voices. It offers a free tier with limited usage and paid plans for more advanced features. There are many ways to extend this project and make it even more useful, like adding more weather data, include information about wind speed, humidity, and UV index. And also you can support multiple languages, allow users to interact with the chatbot in their native language. You can also integrate this application with calendar apps, allowing users to ask questions like, what is the weather going to be like on my trip to New York next week? You can also personalize the user experience, allowing users to set their preferred units of measurement and receive personalized weather alerts. Finally, you can deploy the app to cloud services such as AWS, Google Cloud, etc. I hope you have enjoyed this 3-part series on building an AI weather agent. If you're interested in exploring how AI can transform your business, book a free AI consultation call with us. We are here to help you every step of the way. The link is in the description below and also on your screen. Thank you so much for watching and see you in the next video.